When we think of the simplest form of energy, we think of fire. Coal, oil, peat, or even wood. Humans have been burning whatever they could find as natural resources for thousands of years, creating light, heat, to power engines and to make electricity. Fossil fuels are a one-time use resource, whereas renewable energy comes from sources that are naturally replenished within our lifetime or even daily, forces of nature that can be harnessed.
Forces like the ocean, the power of the waves and the tide. What if we could capture this energy and convert it into electricity? Could there be enough energy in the crashing waves and the ebbing tide for all our energy needs? Can we harness the energy of the sea?
Forces like the sun and the moon exert a huge power over the earth and the sea. As the earth spins, the oceans of the world are attracted towards the moon, creating a gigantic rising and falling of the seas across the planet. As the saying goes, time and tide wait for no man.
The energy we could capture from the tides is inexhaustible. It simply relies on the Earth's rotation, the sun, and the moon.
Then there's the waves. As the wind sweeps across the surface of the ocean, it catches the top of the sea, and this friction between wind and water causes waves. These waves batter our Atlantic coastline all year long. In Ireland, we are surrounded by water, big waves, and in some areas, powerful tides. As an island nation with strong links to the sea and over 3,000 kilometers of coastline, we are perfectly placed to take advantage of this energy.
So how can we capture the power of the waves and the tides? And who's working on this? I want to see if we're getting closer to a breakthrough here in Ireland that could revolutionise renewable energy. The necessity to develop renewable resources like wave and tidal power is becoming more urgent. When fossil fuels are burnt, they emit carbon dioxide, upsetting the fine chemical balance of the atmosphere. This is happening at such a rate, our planet is heading for a catastrophic level of warming. On the 12th of December 2015, world leaders from 187 countries signed the Paris Agreement. Now, around the globe, we are committed to working together to keep temperature rises below dangerous levels by reducing greenhouse gas emissions and essentially phasing out fossil fuels in the next 35 years. Eliminating fossil fuels is a significant challenge, but it will open up a huge market for clean energy technologies. Across the world, trillions of euro will be spent and made on renewable energy. Already, wind power has emerged as one of the cleanest and most cost-effective forms of energy.
There are around 200 wind farms like this all over Ireland, and they're already doing a lot to reduce our CO2 emissions. In fact, wind turbines are already supplying 23% of Ireland's electricity needs.
But wind energy alone can only take us so far. We need a mix of energy sources. Tidal and wave energy are an obvious answer for our island. But how close are we to harnessing the energy of the sea? Lear is the new National Ocean Testing Facility in Ringaskiddy, County Cork. It is one of the world's leading maritime research facilities and brings together science and industry. This facility is the first step for testing new ocean energy technologies. Dr. Jimmy Murphy is one of the senior engineers.
The strategy in Ireland is to put us at the forefront of wave energy development in the world. This facility here in Cork is part of that overall strategy.
At Lear, wave energy devices can be tested in simulated ocean conditions. So this is one of the smaller pools you have here then, is it?
Yeah, this is called the wave and current flume, and it's for generating small-scale waves. It consists of a bank of 8 paddles that are hinged and they flap back and forward in order to generate the waves.
And then you have the device down here in the pool.
We have the device, the waves propagate from the paddles up to the wave energy device, so we can understand how the device behaves when it is hit by different wave conditions.
So you're trying to harness the energy
Harness the energy
wave.
is what we're trying to do in this facility. So we test at very small scale prior to these devices going out into the real environment in the ocean.
And it's an Irish designer then?
It's a Cork company, they're called Ocean Energy, and they've been working on this concept for over 20 years, and they're now reaching a stage where they're going to deploy a prototype out in the ocean next year.
This wave device, designed and made by a small Cork company, has now been funded by the US Department of Energy. This could be the wave machine of the future. The Ocean Energy Buoy uses wave energy to compress air. Under the surface, water enters the open chamber, forcing the air upwards. The force of this air pressure turns a turbine, which in turn generates electricity. When the water recedes, it creates a vacuum. Air rushes in from outside to fill it, and the turbine continues to turn. It's this continuous motion of water and air that drives the electrical generator.
So this is the Ocean Energy Buoy, and this is only 1/50th the size of what it's going to be, and these waves themselves are also only about 1/50th the size. And I can already feel the power of even these tiny waves. And imagine all of the energy funneled through this device when it actually goes out in full scale.
But there's more than one tank at Lear. The deep ocean basin is a bigger tank with bigger waves to test scaled-up models.
Prior to this tank being operational, we would have to go to France or other countries to test devices at this scale. So this really completes Ireland's infrastructure in terms of marine renewable energy.
The deep ocean basin has a hydraulic floor, which allows the depth of the tank to be adjusted.
And why do we want to use these scale models? What's the point?
So it's in order to develop the model at a lower cost than it would be at sea. So we are defining all the parameters of the model, their weights, their dimension, and how much energy they can produce. And we are measuring what the model is doing. So we have 4 cameras that are measuring the motion of the floating body. So we can see the pitch, roll, and all the 6 degrees of freedom motion. And we also measure the pressure inside the chamber. And that's how we extract energy. It's a flow with high pressure through a turbine.
You know, what we're looking at here is a wave propagating across the tank, and what a wave is moving energy, kinetic and potential energy being transferred between one and the other, and it's moving down the tank. So in the real ocean, waves can propagate thousands of miles without losing much of their energy. You know, so they lose their energy eventually when they hit the coastline, so you can hear the noise of the wave breaking. That's the waves dispelling their energy.
Jimmy explained how testing in this tank was important for the early development of the Ocean Energy Buoy, which is now ready for the next stage.
How does this scale up?
So this is a 15 scale model. So the next stage of development is a quarter scale model, which has been tested already in Galway Bay. But at the moment they're building a full scale one for deployment off Hawaii. That device is 36 meters long. So that's longer than this tank here.
That's immense.
It's a huge device, you know, capable of generating over 0.5 megawatt of power.
0.5 megawatt of electricity. That's enough to power about 350 homes.
It's such a big prize. If you can be one of the leaders in terms of developing this new industry, then it can be worth billions to the economy every year. If you go back to the offshore wind, the Danish were the pioneers in that, and now there's a massive industry for them. Can we in Ireland, you know, do the same thing for wave energy?
So can Ireland do for wave power what Denmark has achieved in wind technology? The Danes have the highest proportion of wind power in the world, with over 40% of their electricity needs coming from wind. In the early years, the Danish government subsidised wind technology, investing 30% of the cost to get the industry up and running. Today, they are the largest manufacturer of wind turbines in the world, generating over €10 billion annually for their economy. Denmark is less reliant on fuel imports and can export electricity to neighbouring countries. So can Ireland learn from the Danes' experience? Can we be the pioneers of wave and tidal energy? A wave industry would require a fleet of wave machines and thousands of engineers and workers to make them. The first signs of this Irish wave energy industry are perhaps here, in this workshop in Foynes, County Limerick. Here they built a prototype of a wave energy device called the Sea Power Platform, which was launched in the winter of 2016 and towed up the coast to Galway Bay to begin its first sea trial. Galway Bay is unique in that it has a designated test zone called Smart Bay, created for testing these medium-scale devices. John Breslin from Smart Bay is convinced this will help inventors get their wave machines out of the test tanks and into the ocean.
Smart Bay is Ireland's marine test and demonstration facility. What we have here is we have a licensed test site for taking devices, prototype early stage wave energy devices, and taking them from the lab into the sea. What that means is developers can come to Ireland, they can build smaller models, and these smaller models are cheaper to build. They can deploy in Smart Bay and get it right, and then go on and maybe build another device, tweak it, modify it, and then go on to the full-scale test sites. So it can be done a lot cheaper. It's the difference between single-digit millions and multiples over tens of millions.
In Smart Bay, buoys relay data ashore, such as wave height and wind speed, and instruments on the seabed measure sea temperature, undersea currents, salinity and other data. Joe Murtaugh is heading out to Galway Bay to check on his wave energy converter. It's the first to be tested in this open sea laboratory. He's put 8 years into the design and development of the Sea Power platform.
So Joe, tell me a little bit about your company, Sea Power.
Yeah, Sea Power was set up in 2009 to develop an idea we had for a wave energy converter. It's a very small company, 4 engineers, and we come up with this invention, which has been patented worldwide.
And can you explain then how the device works?
Well, the machine is basically in 2 sections. A large section, which is in front, and the aft section or tail section at the back. And the front section faces into the oncoming waves and responds in heave and pitch to those waves. The back section then responds in the opposite direction. We've configured the design in such a way that both bodies are moving equal and opposite to each other at all times. The power then is centered around the hinge itself. The full-scale machine would be 4, 5 or 6 times the length of this, 8 or 9 miles offshore. You design the machine for the worst. Huge forces, huge wave impacts, and fierce storms.
Joe's vision is to build a wave machine 4 to 5 times bigger, some 60 meters long, and put it further out to sea in the full force of the open Atlantic. Mullet Peninsula was the scene of a decade-long Shell-to-Sea campaign, which saw locals pitted against Shell, a huge fossil fuel multinational. Now this same stretch of coastline could be the future of Ireland's wave energy industry. A new test zone for a full-scale energy device is being developed, 8 miles out to sea. SEAI have been tasked with moving consumption away from fossil fuels and towards clean, renewable energy.
Hiya, Declan, how are you?
Hiya, Lara, good to see you.
Good to meet you. Thank you so much for coming out. Tell me a bit about where we are. What's the significance of this place?
Well, we're actually here, closest point to the continental shelf in Europe, and with the best wild Atlantic waves in the world, where we now, Sustainable Energy Authority of Ireland, are developing a test site for testing full-scale wave energy devices. If they survive here, they will survive anywhere. And you'll see in terms of the size of the waves that we get here in Balmullet are 24 metres. That's a 6-storey building. That's the highest wave, one of the highest waves ever recorded. We have 2 test sites, one 6 kilometres off the coast and one 16 kilometres, 50 metres depth and 100 metres depth. We've been monitoring those sites for the last number of years from an environmental point of view and working with local communities as well. It's a slow process, but it's something that will happen. And we'll see then the devices generating power, and then we'll be able to monitor how those devices are doing.
So the same energy that fills these waves is also incredibly destructive. So it's actually huge design issues.
It is. The wave industry hasn't settled on one specific design yet. At the moment, there are wave devices that go on the top of the waves, where it's incredibly energetic. Others go below the waves, where it's least energetic, but it's more difficult to maintain them. So there's different devices and different types, and all of those have been tested here in Ireland.
So if you can make it work in the most extreme conditions here in Balmullet, then potentially you could make it work everywhere.
Exactly. You can get the I Survived Balmullet t-shirt and then build devices anywhere in the world and know that they will survive. Once we settle on a design, then you can start to make it cheaper and cheaper.
Could we power the whole country?
We could power it several times over with the amount of energy that's out there. 8 million homes could easily be powered, and that's more than we would need, and that's just by wave. 5 to 6 billion a year is what we're importing in relation to energy, fossil fuels. And that is money that could stay here as well. There's a huge resource there that can be tapped by the coastal communities in the West. We can see that by 2050, we could generate 50,000 jobs from the wave and tidal industry here.
So this could be a massive investment for Ireland. It could create jobs and a lot of money for the economy.
Yes, and not only for the economy, but also for the coastal communities along the west coast, and generating energy there and selling that not only to Ireland, but also into Europe as well.
So we could be even exporting energy. We have that much potential.
Yeah, without any doubt, there's no problem. There's that massive opportunity that we have here off the west coast.
So, switching to renewable energy could mean big business for Ireland. If we can tap into this almost limitless resource, not only could we stop spending money on importing expensive fossil fuels, but we could generate income and breathe life back into many coastal communities.
One of the ways in which we can reduce our reliance on fossil fuels is by using electric vehicles. Most of the electricity that is generated to charge our electric cars does come from burning fossil fuel, but a sizable portion of it is already coming from renewable resources, and that portion is only going to be increasing every year. So that's the fundamental difference between driving electric cars and petrol cars.
So demand for renewable electrical power will continue to grow. But we're going to need to look at a whole new distribution of electricity, which is smarter. In a smart grid, fluctuating supply could be balanced, stored, and delivered where and when it's needed. All these power sources could be managed by computers, sensors, and storage so that our supply always meets our demand. But there is one natural resource which is constant. The tide, after all, isn't weather dependent and can be relied on. Has anyone succeeded in making tidal power a reality? On the shores of Carlingford Lough, an Irish company based in County Louth is making breakthroughs in tidal energy. Open Hydro are becoming a world leader in tidal turbine design and engineering. They employ 142 people in Greenore Port, producing tidal turbines for energy companies across the world.
This is one of the first tidal energy devices that Open Hydro built. And while this turbine is 6 meters in diameter, the full-scale turbine is nearly 3 times this size. It's an amazing feat of engineering, and it's built to withstand harsh underwater conditions and constant tidal forces for many years.
Open Hydro's design philosophy is to keep the turbine as simple as possible, making them low maintenance and highly efficient.
So Garrett, what kind of technologies do you design here at Open Hydro?
Open Hydro designs and builds a tidal energy in-stream technology that captures the energy of the ebb and flow of the tide and converts it to electrical power.
And how does it work?
This turbine will be deployed in a very unforgiving environment, 30 to 50 metres underwater, in a very strong tidal stream. We only have one moving part, which is our internal rotor, and we don't have any need for lubrication like oils or bearings or things like that that have a high failure rate for other types of turbines.
How does tidal energy differ then from other forms of renewable energy like wind and solar?
The key difference is that tidal energy is 100% predictable. Because we know exactly when the tide is going to be in and when the tide is going to go out, we can do a long-run calculation and calculate exactly how much power we produce and when we'll produce it, up to 20 years into the future.
They have deployed their full-size 16-metre turbines off the coast of Brittany and in Nova Scotia in Canada. A huge rotor containing coiled magnets forms the basis of the turbine's design. The rotor is then assembled with the outer housing, and the delicate process of moving this 300-ton turbine into the sea begins. A purpose-built barge was constructed for the installation of the heavy turbines. Then it's full steam ahead, out to sea where the turbine will harvest power for many years to come. The turbines are gently submerged into the sea and lowered directly onto the seabed, deep enough so as not to pose a hazard to shipping. This 2-megawatt turbine is enough power for around 1,500 homes. I spoke to Sue Barr from Open Hydro about the environmental impact of their tidal turbines.
So we've always designed the turbine for first principles for the environment that it's going into. So we have no oils and lubricants, it doesn't generate any underwater sound, and it's very benign in terms of its environmental impact. We also have the open centre, which provides an exit route for marine life. And we're also doing a lot of monitoring and marine science to make sure that we're not impacting on the environment within which we're putting the turbine. So in terms of the renewable energy mix, both biomass, solar, other forms of renewable energy, we think tidal energy has a really important part to play in meeting energy targets and in driving down our use of fossil fuels.
The idea is to build tidal farms with a cluster of these devices that will provide power for large towns and cities.
So the Earth's oceans are a vast and renewable resource that can be used to create power for our towns and cities.
Transitioning to renewables will take a lot of planning, finance and commitment. That much is certain. Investment in our ocean energy technology will create jobs and move Ireland towards energy security, as well as reducing our impacts on climate change. That really is something worth striving for.
Renewable energy poses some challenges, but in the end, we're faced with a choice: to continue importing expensive fossil fuels and ignore climate change, or to adapt to technologies like wave and tidal energy, which offer us a real future. Ocean energy could be a uniquely Irish solution to a global problem.